uniform distribution. And then we will see what is normal distribution. Finally, we end up with the areas under the normal curve. Continuous uniform distribution. One of the simplest continuous distribution in all of statistics is the continuous. So when the random variable takes any value between in an interval, when you know that x is a random variable and it falls between 0 and 1 or a to b, whatever the interval. So we know that x takes every value between this one continuously is going on. It's not discrete, isn't it? In this case, we know that the distribution, the property distribution is called, for this random variable, if you write property distribution function, p of x is equal to x or small f of x. This is called a continuous distribution. So among the continuous distributions, the simple form of a continuous distribution is called a uniform distribution. The distribution is characterized by a density function that is flat, and thus the probability is uniform in a closed interval AB. What is it? The density function of the continuous uniform random variable x in the interval AB is given as, see, when you get a function like this. B1 over B minus A, and this is defined by the lower and upper limits of the interval. If x is a random variable falls in an interval A, you can take it a closed interval or open interval, doesn't matter. B, A and B. So 1 over B minus A. If you get such a constant function as your property distribution function, this is called a uniform distribution. It's called, so this distribution, the probability is depending on the n points of the interval, nothing else. N points on the interval. So whenever the interval is larger, the value of the function will be smaller. The length is an interval and is more, than the value of the function will be smaller. That's the reason. And this in this, we call this one uniform distribution, we call it constant distribution, we call it rectangle distribution. There are many different names for this distribution, because when you draw this one, it will be looking like rectangle on the xy plane. The density function forms a rectangle with the base b minus a and a constant height 1 over b minus a. Yes. Do we have a graph? No. If you draw this one, see, you can check Dirac delta function is an example of this one. I can write here f of x is b minus a, isn't it? So if x lies between 4 and 10, the base is the difference, 6 units, isn't it? The height f of x is 1 over 6 will be the height. If 1 over 6 is found, it will be here, isn't it? When you come closer, the height will increase. When you come more closer, height will increase. It will go like this, isn't it? So this kind of graphs you will get. So we call it rectangular distribution as well. We call it rectangular distribution. The mean and the variance. So we know that some standard distributions have a general formula for mean and the variance. We don't need to calculate it by using expectations. We can directly find the mean and the variance of uniform distribution if you know the upper and lower limits of the interval. And now we understand one thing: uniform distribution is a continuous probability distribution. It involves two important parameters. One is lower limit, another one is upper limit. If you know upper and lower limits, you can find all properties, mean, variance, everything. That's why we call the parameters of uniform distribution as A and B, the upper and lower limits. Fine, the lower and upper limits. A is lower, B is upper. So average, you can find E of x. You can still use the formula E of x For continuous random variable, we will use integral x f of x, and f of x is 1 over b minus a dx. We can integrate from a to b and check. You can integrate, find expectation, check this whether you get this answer or not. Okay. Now, variance b minus a whole square over 12. So standard formulas have been given for finding mean and variance. Next is normal distribution. Most important probability distribution in statistics is called normal distribution, because here we are going to study a formula for z, a new variable z, converting one random variable into a new random variable. The known random variable is x, the new random variable will be z. We will find such a formula here, and there is a table in the textbook. We are going to use z table. This is a normal distribution, gives a lot of applications in our real life and engineering. We will see some of the applications in this class and the next class as well. Most important probability distribution is in statistics. The graph is the famous bell-shaped curve. I will show you. If x is a continuous random variable with normal distribution, with mean mu and variance sigma square. Mean, the notation is mu, we know. Variance is sigma square, and it's a probability density function. Yes, given here. We know uniform distribution is depending on two parameters, the lower limit and upper limit. So here, normal distribution is denoted by small n. It depends on two parameters, mu and sigma. Mu is mean, and sigma is standard deviation. So you will be given variance. From variance, you will find sigma and then use this formula. What is this formula? In other words, this exp stands for e, exponential. So 1 over sigma times 2 pi e raised to minus, we call it z over z square over 2, where z is x minus mu over sigma. This is going to be the major part of this topic, isn't it? Z is equal to x minus mu over sigma. So is a square. So this all x minus mu sigma, everything is in square. So it will be z square over 2, isn't it? In other words, we can write this way. This is the probability density function of a normal distribution when the random variable is allowed to move from negative infinity to positive infinity. Okay, 1 over, here it is square root of 2 sigma. In the denominator, 1 over sigma into square root of 2 pi. That is what to be remembered. This is the formula actually for normal distribution. And the question is, should we use this normal distribution formula throughout this problem? No. We will convert this normal distribution into standard normal distribution, and then we have a shortest method to use. We'll use it. Now the normal distribution is often referred to as the Gaussian distribution to honor Carl Friedrich Gauss. He's a famous mathematician, most popular mathematician. Many theories have been there in his name. During his childhood, you know, there was a formula called n and n plus 1 over 2. This is sum of the first n natural numbers. It's defined by Carl Friedrich Gauss. During his childhood, the teacher asked him whether you can. It was an open question to all students whether you can add hundreds, first 100 natural numbers without any trouble. Then this guy has gone with a different idea. He has added 1 plus 100, which is 101. 2 plus 99, which is 101. Let's go on this way. 2, 3 plus 99 is 98, 101. He ended at 49 plus 52, 101. 50 plus 51, 101. Now, it's very easy. There are 50 rows because ending with 50. 50 rows, 50 times 101. So, if you want to add 100 numbers, then 50 times 101 will give you the answer, isn't it? And further, you can simplify this one 101 into 100 divided by 2. This is the formula. This was defined by Carl Friedrich Gauss. So, to honor him, they have named this distribution as Gaussian distribution. And now, we are going with our normal distribution. A continuous random variable x having the bell-shaped distribution is called a normal random variable. So, if you find the probability and draw the graph by using any graphing abilities, it should give you a bell-shaped curve. In such a cases, we call the random variables normal random variable. So, this mean value is here. This is mean value, isn't it? Mean value. Standard deviation gives how far the data is deviated from the mean, isn't it? If variance is more, it will be wider. Variance is, standard deviation is smaller, then it will be closer to the mean. In this case, standard deviation is small. If it is wider, the standard deviation is more. Mean is a midpoint here, right? Fine. Are you guys following? Remember that the area under the probability curve must be equal to 1 because total probability is 1. So the area from here to this end, from this one, x takes from values from negative infinity to positive infinity, isn't it? So the entire area is considered to be 1 because the total probability is 1. So first half, area in the first half is 0.5 and second half is also 0.5. So if you take some value here, some z value here, for every x you can find an z value here, the area below this z will be more than 0.5, more than 0.5, maybe 0.6 or 0.7. But if you take any value of z here, the area below this one will be less than 0.5, less than 0.5, maybe very small, 0.1 or something. So this basic idea should have been there with us to proceed with. Well, the area under the property curve must be equal to 1, and therefore the more variable the set of observation, the lower and the wider of the corresponding curve will be. So what do you see here? See the normal curves. For mu1 is less than mu2. So three different curves have been given here. So here, therefore, the more variable the set of observations, the lower the and wider the corresponding curve will be. It means that if you have more data, the curve will be very lower and wider, isn't it? Fine. Normal curves with the mu and two different means, so two different curves, isn't it? And with the equal standard deviation. See, the data are equally spread. The first graph, the standard deviation is sigma 1, so data are varying sigma 1 from the mu 1. So both have equal standard deviation, so they are looking alike, isn't it? But different means. We have different means. In the first graph, we have different means. Mu1 and mu2, they are different. Mu1 is smaller. This is a real axis increasing order. So this is, if this is 3, this should have been 4. So mu1 is smaller and the standard deviation is equal. So mu1 gives the height, in the same height, isn't it? And standard deviation gives the distribution actually. how it is deviated from this. So they are looking alike because the standard deviations are same. Second graph, mu1 equal to mu2. I mean, mu1, this value, this value is same on the x-axis. This is 3. If it is 3, then both are 3, isn't it? And this data is more. The first one is sigma 1 is smaller than sigma 2. Smaller than sigma 2. So when sigma 1 is smaller, very small, this gap is very small. Sigma 2 is bigger, this distance is small. So it is spread, too much spread from the mean. And the mean gives the center point, isn't it? Center point, and this will give you the maximum. I mean, there are more data with this mean, with this close to mean. That's the meaning of this height. There are more data very close to mean, and the deviation is very small. So the data are not too much deviated from the mean. They are very close to the mean, isn't it? In the first graph. For the second graph curve, the data is highly deviated from the mean. It's a little bit far away from the mean, isn't it? But in this case, both the means are same, standard deviations are different. Case 3 here, both are different, isn't it? Mu1 is mu2 lesser than mu2. So the first number comes here, second number in this order, direction it goes. And standard deviation is sigma 1 is lesser than sigma 2. Both are different, so different curves you get. I think you might have got an idea about the role of mu and sigma in the normal curve. Is it clear? Properties of the normal curve. First property, the mode, which is the point on the horizontal axis, where the curve is maximum, occurs at x is equal to mu. This is called a mode, the highest point. This is the mode. Occurs at x is equal to mu, the mean. When x goes this way, x takes all values from negative infinity, positive infinity. X takes some value mu. That mu gives the mode. Next point is the curve is symmetric about the vertical axis. About mean. See, about mean. Go to the graph. This curve is symmetric. This is your mean vertical axis. Mean is assume that mean is your vertical axis. Then it is symmetric on both sides, looking alike on both the sides. Third property. The curve has its points of inflection. You know what is points of inflection? Points of inflection at x is equal to mu plus or minus sigma. See, another beauty in statistics, if you have a lot of data, assume that you have 100 different data information, all the data will fall within the range mu plus or minus 3 sigma. It is called 3 sigma policy. All the data, 99% of the data will fall in this interval. What do you mean by this one? Mean is the center point normal curve. So to take mean, add standard deviation, you will get this point mu plus sigma. This side you will find mu minus sigma. In this interval, a certain 60% of data will be there. Here, another interval you can find mu plus 2 times sigma here, mu minus 2 times sigma, and finally you can find mu minus 3 sigma, mu plus 3 sigma, bigger interval. In this interval, mostly 99% of the data will fall. That's called a 3 sigma policy in statistics. So what we are suggesting is the curve has inflection point here, mu plus sigma, mu minus sigma. When you check the curve will change its orientation towards up. It was looking like this one, isn't it? So that's what the inflection point might have been studied in calculus 1, calculus 2, calculus 1, I think. Okay. What is it? Again, the graph. See, if you know what is sigma 1, this value, you can add a sigma 1 with a mu. You will find another value of x here. So maybe this is mu 1. Here, the concave down becomes changing into concave up. So this is a point of inflection. So points of inflection of the curve occurs at x plus or minus x plus and minus mu, isn't it? That's for the point 3. So it's concave down in the first interval. So in the first interval, this is mu, this is mu minus sigma, this is mu plus sigma. In this interval, it is concave down, and beyond this, it is concave up. Otherwise, it's concave up. That's the point. The normal curve approaches the horizontal axis asymptotically as we proceed in either direction away from the mean. What's the meaning? This is the normal curve. Roughly, I'm telling the curve approaches the axis asymptotically, never touches this. It will go after some stage. It will go parallel to the x-axis or z-axis, but will not touch this axis. It will go very parallel to this line. Will never touch or intersect this line. Okay, that's what given. These are the properties, isn't it? Can be used for MCQs. The total area under normal curve and above the horizontal axis is equal to 1. That's, we have already seen this one. Now areas under normal curve. So we will complete the theory part, then we'll go to exercise problems. Areas under normal curve. The normal curve of any continuous probability density function is constructed so that the area under the curve bounded by the two ordinates x is equal to x1 and x equal to x2 equals probability of this one. What do you understand of this one? If we are given two x values, finding probability by using this formula is easier. Without this formula, we can use easily. We can find the probability by using the normal curve. We don't want to integrate everything. So probability of x1 less than the random variable falls between two values. Assume that this is 1.5. This is, negative 1.5. This is positive. 0.5. So this is negative 1.5. This is, if mu is 0, let this be negative value. This will be right, positive value. Then here it is negative 1.5. Here it may be 2.5. You can take. So the probability between 2 points is the area. How to find this area without integration? We have a table. Now we call it normal curve table. The table will always give the area below this number. If you refer the table for the value 2.5, if it's not x, it will be z. We have to find z by using x. X minus mu over sigma is called z. We use this formula, which is taken from here. All right. Okay. And we find is that this line is actually representing the new random variable is that here. If for x1 we find one z, another z here, the table will give you for z is equal to 2.5, the entire area below this line. And for this value, this entire area below this line. So when you subtract this area, you get this area. So we will work it out. Don't worry, we take examples and we will practice it. So area of the shaded region. We are integrating actually the probability density function from x1 to x2. You understand it? But it can be done without integration by using a normal table. You are allowed to use the table in all exams. We are able to transform all observations of any normal random variable x into a new set of observations of a normal random variable z. We are going to convert x into z, then use the table. With mean 0, mu is 0, and the variance is 1. mean is 0, then center point becomes the mu, the axis. This point will be 0, isn't it? This point will be 0. Left hand side you will get negative values, right hand side you will get positive values. Okay. With the mean is 0, variance is 1. This can be done by means of the transformation. Z is equal to x minus mu over sigma. Okay. If x falls between the values of x1 and x2, then the random variable z, the new random variable z, will fall between z1 and z2. Z1 can be found by using the same formula, this formula. The same formula, whatever written here is given here. But for finding x1, this is finding z1 using x1. This is finding z2 by using x2. And we write property of x lying between x1 and x2 is equal to property of z lying between z1 and z2. So when you know the values of z1 and z2, you can easily get the property of this one from the graph. You will see it. And you remember, for continuous distributions, equality has no role, because you remember always integral from a number to the same number will be always 0. So equality has no role when or there is a continuous distribution. Okay. Definition: the distribution of a normal random variable with mean 0 and variance 1 is called standard normal distribution. So we are converting a normal distribution into standard normal distribution by using this formula. This formula is it? This formula given here, isn't it? Okay. So the resulting variable is that will be called standard normal distribution, whose mean is 0. So center point will be the peak will be attained at 0, and variance is 1. So standard deviation is also 1. Exercise starts now. Exercises. So the daily amount of coffee. Read this problem. We will solve it. What is it given? Is it normal? See, we have studied only two different distributions. One is uniform distribution. Another one is normal distribution. For uniform distribution, to find any property, you need only two information: lower limit A and upper limit B. Everything should be happening in an interval, right? Another distribution, normal distribution. For normal distribution, you need mean and variance or standard deviation. That's it. So read this problem, understand which distribution is given. Most of the time, the problem will give you the name of the distribution. The daily amount of coffee. The daily amount of coffee in liters dispensed by a machine located in an airport lobby is a random variable x. The real life application. Randomized x having a continuous uniform distribution with the A is equal to 7 and B is equal to 7. We got it. They have given the name uniform distribution. So uniform distribution totally depending on A and B. What is A is 7 and B is 10. That's almost we are done now, isn't it? Now, if you are looking for mean and variance, we have standard formulas. Otherwise, the question is the probability. Find the probability that on a given day, the amount of coffee dispensed by this machine will be. So we are finding probability. What is notation? At most 8.8 liters. What do you write? At most. What do you mean by at most? Maximum or minimum? At most, maximum. So the coffee dispensed by the machine to the maximum is 8.8. It is allowed to give up to 10. Minimum it gives 7 liters, isn't it? Maximum 10 every day. So what is the probability to get maximum 8.8? That's the question. What is the chance? Probability of capital X is greater than, isn't it? No, is it not? It's not greater than. mm, less than or equal to, if you ignore the equality, nothing will happen, don't worry, right? In this case, because this is continuous distribution. Probability of x less than or equal to 7.4 liters. This is the meaning. At most 7. Okay, I'm talking about question number A. It is 8.8. I'm talking about question number A, this part. So at most maximum 8.8. So can be lesser than 8.8. Anything lesser than 8.8. But you cannot get less than 7, because obviously minimal limit this uniform distribution is valid here between 7 and 10. So your lower limit is 7. So integrate the probability mass function f of x dx minus infinity to 8.8. We should integrate actually, but not minus infinity is our lower limit. Our lower limit is 7, which is 7 to 8.8. And remember, what is the probability mass function? Probability density function for continuous distribution f of x. Here it is 1 over b minus a, 1 over 10 minus 7, which is 1 over 3. So this is 1 over 3 here, the constant. And dx, 1 over 3 is constant, take it outside, 1 over 3. Now integrate dx, you will get x. It is from 7 to 8.8. So now substitute the upper and lower limit. 1 over 3, 8.8 minus 7. Use calculator. You will get 0.6. So let's go for the second problem. B. Let's go to problem number B. And remember, what is your a, b, f of x is 1 over 3. This should be remembered, because I am going to erase this. B. So the problem part B. Probability of x more than 7.4. So it is greater than 7.4 and less than 9.5. Obviously integrate from 7.4 to 9.5. The function f of x is 1 over 3 dx. And what you get here is 9.5 minus 7.4 over 3. That's it. It will be 0.7. Use calculator, you will get 0.7. Now see, at least whenever you get at least, at most gives maximum. So less than or equal to will be used. At least gives minimum, so greater than or equal to should be used. X greater than or equal to 8.5 can be integral from 8.5 to upper limit is positive. What is upper limit here? 10. And f of x is 1 over 3 dx, which is 10 minus 8.5 over 3. This is easy for uniform distribution, because when you integrate dx, you will get x, and when you substitute upper limit and lower limit, you will get 10 minus 8.5. Very easy, isn't it? Divided by 5, it will be 0.5. That's the end of this problem. The solution is on the separate sheet. Actually, PowerPoint you can find. This PowerPoint will be available online on Blackboard soon. Question number 2, 6.4 from your textbook. A bus arrives for every 10 minutes at a bus stop. It is assumed that the waiting time for a particular individual is a random variable with a uniform distribution. Uniform distribution is given. Interval length has been given 10 minutes. So you form the interval. What is your starting point? Let A be 0, B is 10. Therefore, the limit will be 10. The interval length will be 10 minutes, isn't it? So we assume starting point is 0 and ending point is 10. For a uniform distribution, we want the interval. So interval length has been given as 10 minutes. So starting point A is 0 and ending point B is 10. That is okay. So we got A and B. Now we can straight away answer. What is the probability that the individual waits more than 7 minutes? More than 7 minutes. Answer is probability of X is more than 7. Is strictly greater than 90, but there is no meaning here in continuity. For discrete case, equality plays big role. But for continuity, it's all integration. From 7 to maximum 10. Because 10 minutes you can wait. Minimum 7 now. And what is f of x? What is f of x? 1 over b minus a, which is 1 over 10 minus 0, which is 1 over 10. So this is 1 over 10 dx. So this is 10 minus 7 over 10, and 3 over 10, which is 0.3. Question number B. What is the probability that the individual waits between 2 and 7 minutes? So the random variable falls between 2 and 7. So integrate from 2 and 7. 1 over 10 is the probability density function dx. So 7 minus 2 over 10. The answer is 5 over 10, 0.5. It's done. Now different work is to be done. The answer is also here. That's it. Given a standard normal distribution, read this one. Given a standard normal distribution, find the area under the curve that lies. Okay, what is this? I will show you the normal table now, and I will explain how to use them. Before that, I will give a rough idea. This is our normal table, isn't it? Normal curve. Center point is mean, and it is 0 here, right? Left negative values, right side positive values. For Z is negative 1.39, so it will be left side of this mu. Assume that this is negative 1.39. Now draw the line here. The question is, what is the area below this line? The total area is 1. Entire curve covers area 1, but the first of area is 0.5. But there is a normal table which will give you the direct area less than for any Z value. Now, if I go to the table and I check this value in the table, the value available on the table will give you the area below this point. Are you here? Shall we go to the normal table now? Okay, normal table. This is the normal table. Can you see? Okay, what we need to do, this is if this is Z value, see here, if this is the Z value, the area below the Z value is given all over this table. This table is available in your textbook that I have uploaded on the Blackboard. The page number is 735. You can go, the table is called A3, A.3. normal probability table. This table is available on your textbook. You can just print the particular part or particularly take that particular part, page number 3735. Okay, let's find what is the value we are looking for. Z is negative 1.39. Come down, huh? We'll take it. Negative 1.39. You remember it? Negative 1.39. I'm going for the table again. Negative values are given on the first page, positive values are given on the second page. First page, negative 1.39. 1.3 here, negative 1.3. 9 go to 009 is at the end. Is it? Negative 1.39, isn't it? Negative 1.3 will be in the left column. See, there is a title column for Z. There is a title row and title column. This column and this row should be used to identify the area inside. Now 1.3. Where is 1.3? This is 1.3. Have you noticed? Negative 1.3. 009 will be 9 will be the last column. So 0.0823. 0.0823 is the area below this value. Is it clear? If there is anyone who didn't understand how to use normal curve, please ask me. So the given Z value is, go into that table. Table 5, right? So from the table I did find that is, so I'm actually what I'm looking for problem number A is, this is normal curve. My mu is somewhere here, which is the center point, and Z is here, which is negative 1.39. So the area to the left of Z, straight away from the table we are finding. In the table we go to the Z here and here. Here it is 0.00, 0.01 up to 0.09 in this column, because the last value is, this is 9. In this column, negative 1.3, they meet at this point, negative 1.3 and 0.09, which would be, when you count this one with this one, it will be negative 1.39. So there is a value lying at the intersection of this row and column. So the value that we have taken from the table is 0.0823 from the table. Now my question to you, then what will be the area from here above Z? If I ask you area right side of Z, what do you do? We know from the table we found this area. This area is 0.0823. The area below Z. Now if I ask you up right side of Z, what is the area? We should subtract from 1, because total area is 1. 1 minus 0.0823. Subtract and get this area. If I ask you only this area between negative 0.139 and 0.0, this area, only this area, we should subtract from 0.5, because this entire first half is 0.5. Another second. So 0.5 minus this value will be the area of this part. Okay, that is 0.5 minus 0.0823 will give you the area of this part alone. In this way you can play with the graph and the table. Okay, now here we go. Second problem. To the right of Z, now it's not left, be careful. But the table will give you only the area to the left of Z. You are going to find the area right of Z. Okay, 1.96. where it will be roughly draw the graph. Okay, first I will find the value left of z, and then we have to calculate the right of z. 1.96. Go to the table. The positive values of z is like in the second 1.9. Here we go. Here we got 1.99006. 0.06 is here. So in this column, come down against 1.96. So 0.9744. So 1.969744. Is this? Oh, this is 0.5. This is 0.6 here. 0.6 gives 9750. 9750. 1.906. So 1.9 plus 06 will give you 1.96, whose value, the left value will be 9750. The curve always gives the area to the left of the z value, isn't it? Right, it should be calculated. So 1.969579750. Note down this one. Okay, so let me start the open again. For this normal curve, a roughly normal curve. This is your mean mu, which is 0% normal division. Okay. Z is 1.96 in the right side. Z is 1.96 in the right side because it's positive value. Now the question is the area under the curve to the right of Z. You have to find this area, but the table will give you the area below the curve. We have found it, which is see, area probability of is at less than 1.96 is given from the table that 0.9750, isn't it? So what is above I mean right side of z, which is, now we can write this one, probability of area is probability here, probability of z greater than 1.96 is 1 minus 0.975, because the total area is 1. So when you remove this area from total area, you will get this part, isn't it? So 1 minus 9750, which is 1 minus 0.9750. So it will be 0.025. That's it. For second problem, we have done. Is it clear somewhat how to use the normal curve? Now it is different. Third case, between a negative, two negative values. Between two, when you get between, how to solve it? The area to the left is called the probability of z, isn't it? Okay, this curve is for z values. Now, here we go. Let me draw this one. Before drawing this one, we need the values of z left side of negative 2.16 and negative 0.64. Let's go to the table first. Let's go to negative 2.16, negative 2.16, negative 0.65. Remember these values. And now go to the table. Negative 2.16. Negative in the first page. Negative 2.106. Can count 0, 0, 0, 1, 2, 3, 4, 6 here. Come down. Negative 2.16. Negative 2 point here 1. 6, 0.0, this is 0.5, this is 6, 0.0154, 0.0 0.0154. This is for negative 2.16, 0.0154. Another value is negative 0.65, negative 0.6 here, 5 here. 0.60, 2, 3, 4, 5, 5 here. Check 0.5, yes. 0.65, 2578, 0.2578. So note down these two values. I'll come back to this PowerPoint. From this side, I will draw the normal curve. The center point where mean is 0, isn't it? Left side will be negative values. Both the values are negative, so both are lying left side. See, the closer value is negative 0.65, this one, and the further value is negative z.16, negative 2.16. So the area between these two, how to calculate? Now we know the area left side of negative 0. From the table we have found two information. One is left side of this one. What is it? Probability of is less than negative 0.65 from the table. It is 2578.2578. So the area below this curve, first bigger, isn't it? Is entire area. This entire area is 0.2578, from which we need to remove this part. So probability of z less than negative 2.16 is 0.0154. Subtract it. So remove this one. So you will get this area. From the bigger area, you subtract this part, and you will get this area. So what is it? 24. So 4242. 0.2424 is the answer for case 3. SC. Now to the left of, it's very easy. Just from the table, find where is left of is equal. Question number D I am going to do. This positive value of is there. So it will be right side somewhere here. 1.43 to the left. Directly from the table you will get what is probability of z less than 1.43. Directly from the table, go to 1.4 in the positive page and 0.03 in the top. For negative 1 point in the table, we will check the answer I am writing here, which is 0.9236. We will verify this one for question number D. 9236. Less than 1.43. Z is less than 1.43. Positive values 1.4 here. This is 0, 1, 2, 3 here. 9236. This is the answer. Okay, we have done. We have done this one. Now problem number to the right of negative 0.89. So first we should know what is to the left of 0.89. Then we will subtract from 1, isn't it? Okay. To the left of negative 0.89. What is it? Negative values are here. 0.8. is here 0.89, last column 1867, 0.1867, 1867, isn't it? So come back here. I'm talking about problem number E. This is the curve, this is the normal curve, center point, mu, negative 0.89 is somewhere here. So this line is to the right side of has been asked. This area is what we are asked to find. But from the table we will find this area as 0.1867. So how to find the area on the right side? So the answer is 1 minus 0.1867. It is 0.8133. So right, isn't it? To the right of the value. Now again between two values, just like a C. But here both are negative values. In this case, one is negative and one is positive. Okay. I think I leave this one to you. You can try and find. The answer is on the board. See, negative 0.4, negative 0.48 and 1.74. So we will find the left side of 1.74 area and then subtract this one. It is given here because the curve from the table you will find that this normal curve and 1.74 will be here, negative 0.48 will be here, isn't it? So this area is what the question is looking for. First, find the area below the big number. It's this area below this 1.74 from the table, which is 9591, and subtract this area, which is 0.3156 from the table 0.48. From the table 0.4 and I go to the eighth, last but one column. So you will remove this area, you will find this area. I hope you are understanding. If you are not, come for discussions. Now this problem is good. We need to have the random, the normal distribution table. We will try to finish this syllabus. It is problem number 4. Find the value of Z if the area under standard normal curve. Now the reverse task. The area is given. The reverse task of the previous one. The area is given here. See, I will draw again here for you. What is given is not Z value. This is normal curve. Assume that is looking perfect. And you have been given an Z value. We don't have an idea that Z is positive or negative. Can you conclude Z is positive or negative? The area is given here. It is 0.3, not more than 0.5. If the area is more than 0.5, it should be right side. If the area is lesser than, no, it is right side. The area on the right side is given. So actually, the right side area is just 0.36. You are supposed to find the left side area. So it's not more than 0.5. So it should be here. If it is more than 0.5, it should have been here, because the entire of is 0.5. So the right side area is given. This area is given, which is 0.3622. And we can say what is the left side area. Subtract from 1. 1 minus 0.3622, which is 0.6378. So this area is 0.6378. Now for this area, find Z value from the table. Find Z value. That is the question. 6378. Remember this one, 6378. Now for this value, we'll find Z value. Let's go to the table. 6, 3. Problem number 8. Go to the area now. Go to the area. Where is 6, 3, 7, 8? It's not in this. The maximum area is 0.46 in the first half. So 6, 3 is in the positive direction. Come here. 6, 3, 7, 8. 6, 3, 6, 8. 6, 3, 6, 8. This is the nearest value. We don't have 6378, but the nearest value is not 6406. The nearest value to our 6378 is 6368. This is nearest value to the area. This area will give you leftmost part 0.35. 0.3 from the left side column, 0.5 from the top row, isn't it? So 6368 is the nearest value to the our areas given in the problem. In the problem, to subtract from 1, you'll get 6378, isn't it? This 6378 is nearer to this value, 6368. So from the left end, you will find 0.3. From the top, you will find 0.05. Sum them up, you will get 0.35. The answer here it is. The answer is the Z is. Your question is find Z. Find the value of Z, not the area left or right. The given is right side area is given. By using the information of right side area, we are finding the value of Z. Z is 0.35. Now you will do the same task for this one. We are supposed to find only Z value. You are given an information. The left area is given. Straight away, go to the normal table, and this area is not more than 0.5. So it should be positive. So left area is lesser than 0.5. So it should be left side here. So there should be some negative value. This area has been given. What is the area? 0.1131. For this area, straight away go to the table and find this 1131, isn't it? So probability of Z less than 0.1131 should be found from the table. Table 0.1131. 0.1. Where is 0.1? This area should be 0.11 in the negative side, and 1151 available. 1131 is here. It's here, isn't it? The top title calls 0.01, now 1.2. Okay, here 1131. This will give negative 1.01. So 1.2 plus 0.1. It will be from this left side. It is negative 1.2. Add the top value 0.01. So 1131 gives Z value. That Z value negative 1.21. That is it. Now find between 0 and Z. 0 is middle value or area. I mean the mean. Z greater than 0, positive value is given. What is given? Not the entire area below. It is given that from 0 to Z. 0 to Z. Z is positive. The area is given as 0.4838. Now find Z value. But we know this area is 0.5. The entire half is 0.5. Add them. So you will get 0.9838 is the area below Z. The area through this below Z is 0.9838. Now for this area, fine. for 9838, we will find a Z value. Skip table. The area is 980, so in the right side, a positive value. You can find 9834 somewhere here. 9834, yeah, we got exact values. Sometimes we won't get exact value, we get to take nearest values. So this is the area, 9834. 2.1, go to the top, 03, 2.13, is it? 2.9834, oh no, 9838 is our answer. 9838, isn't it? We have added this one with the 0.5, so 9838. 9838 falls here, the top will give reads 0.04, so 9838 with the left extreme value 2.1 plus 0.04. 2 points, the answer here it is. The value of Z is here. Z is equal to positive 2.14. Now between negative Z and positive Z, same value of Z on both sides. The total area is 0.95. How do you get? You should have an idea, should have a clue. This is normal curve, isn't it? Middle value 0, left side negative value, right side. So there is a negative Z here. The same Z appears here on the right side, same value, same Z, not two different 0 and 2. They are same. So if you get negative 1 here, positive 1 here. If it is negative 2 here, positive 2 here, right? So we don't know what is actually Z. We are going to find. But the given information, the area between them, this area between them is 0.9500. If you know the entire area, you can find it. This is Z value. So write the same Z negative sign, you will find it. So how to find the entire area? What is missing here? What is missing in this end and this end? Same, because this is symmetric. Whatever missing here will be missing here. So from 1, subtract 9.95. 1 minus 0.95. What is it? 1 minus 0.95. 0.05. So this area is lying on two ends. This side and this side, totally 0.05. Divided by 2, we get 0.025, which is this area and this area. This area is 0.025 and this area is also 0.025. Now add with this one, you get total area up to Z. Up to Z. So what is the probability of Z lesser than some value of Z, isn't it? Lesser than this value. Call it this. This is capital Z. This is small Z. Okay. Is sum of these two. 0.0250, 0.9500. What do you get? 0.579, 0.9750. Isn't it? Okay. Now for the area. (9750) we will find Z value. 9750 will give Z value. So if you find Z value positive, then it is same negative. 9750, 97 somewhere you can find here, and 9750 is obviously here above 06. Okay, 9750. 1.9 in the left extreme end, isn't it? So 1.9 joins with the 0.6 will give you the Z value. 9750 is 1.9 96. So for this problem, last problem, positive z value is 1.96. The same will be negative z. Negative z is negative 1.96. So z is, question is what is z? That is the answer for this question number D. The answers have been given here. You can read it. Given a normal distribution, we have 10 more minutes to go. I think one more problem can be solved. We have 3 more problems to finish. Let me complete at least this problem. Problem number 5. Given a normal distribution with the mean and standard deviation, find the normal curve area to the right of x. X isn't it? But we are finding to the right of z. So we need to find z for every problem given here. So what is the way to proceed? Problem number 8. Find z. The formula for z is x minus mu over sigma. X for problem number 1 is 17 minus the mu is 30 given here mu. Standard deviation is given here. Divided, you will get negative 2.17. Now the area to the right of x. How to write this? Probability of to the right x is greater than 17, which is equivalent to z is greater than negative. I repeat here. Our mean is 30, standard deviation is 6, so the probability of x greater than 17 because to the right of x, isn't it? That is equivalent to probability of z to the right of z value. How to find z value? Z is x minus mu over sigma. X is 17, mu is 30 given here, divided by 6. So for the first problem, z value is use calculator negative 2.17. Okay? So z is greater than negative 2.17 is. Now if you find the normal curve, you will find z is the left side, isn't it? Here negative 2.17. Now we want the area to the right of this value. So find this area, subtract from 1. So from the table, what is it? So 1 minus probability of z less than less than negative 2.17. So from the table, you will find this area as negative 2.17 is 0.015. So when you subtract it, you will get 0.9850. Last let's see right here. Read the problem. A soft drink machine is regulated so that it discharges an average of 200 millimeters per cup. Average is been given in the mu. If the amount of drink is normally distributed with a standard deviation equal to 15 milliliters. 15 is our standard deviation sigma. So we have got two information here. 200 200 is our mu. 15 is our standard deviation, isn't it? So let the information mu is equal to 200, sigma is equal to 15, standard deviation. Now come back to the question. See, though there is an integration for continuous property, we never use integration for normal distribution. We are using the normal table. What fraction of the cups will contain more than 224 milliliters? So we have to find the fraction. What fraction means probability, isn't it? What fraction of the cups is a probability? 224 x. See, probability of x is given for this case. X is random variable value. X is 224. So find z. Z is equal to x minus mu over sigma. 224 minus 200 is more than the average, isn't it? Divided by 15. Use calculator. It is 24 over 15. Check, is it 1.6? 1.6 or check your answer. Okay, I'll leave this verification to you. 24 over 15. 8 fours are 8 fours. Okay. 8 threes are 24, 5 threes. Now, more than 224, isn't it? More than 224. That should be done like probability of x greater than 224, which is equivalent to probability of z is greater than 1.6. So the area above 1.6, isn't it? Right side of the endpoint. So we have area only in the left side of the table, which is should be written as 1 minus probability of z less than 1.6, less than or equal to, actually if there is no equality here, equal to 40 seconds, isn't it? Right side. But in continuous case, equality has no rule. Let's write 1 minus, what is the probability of z, which is less than the area under the normal curve, which is left side of the value z is equal to 1.6. And see, if you find it here, you are finishing. So when I move out of this PowerPoint, all these letters will go. Okay, I will show you again in the table. Is it is 1.6, positive 1.6, 1.6 here, 0, 0 here. So which is 0.952. 0.9452. Which will give 0.9452. Remember it. So we will do it here. That is probability of 1 minus probability of z less than 1.6, which is 1 minus 0.9452 will give you 0.0548. That's the end of problem number A. Next, for problem number B. B. X is between 191 and 209, and we have our mu and sigma. So this is x1, this is x2. For every x, find z. X1 is 191. Therefore, z1 is 191 minus 200 divided by 15, which is negative 0.6. Verify this one. X2 is 209. So Z2 is 209 minus 200 divided by 15, which is the same distance 9, isn't it? It's a 9 on both sides, so it will be 0.6 positive. So 0.6 on both the sides. So our normal curve lies, this is the normal curve. Here the area lies on both the sides, negative 0.6. Here it is positive 0.6. The area between this one has been from the table we can find the area up to positive 6. Positive 0.6 and again area up to negative 0.6. So when you remove the second area, this area from this area, you will get this part, isn't it? That's what we are going to do. So we will write this formula as probability of x1. How to write x1? 191 less than x less than 209 is equal to probability of negative 0.6 less than z less than 0.6. So we need to find the area left side of point positive 0.6 and left side of negative 0.6, isn't it? Then we are done. Okay, here we go. From this one, find the probability. Positive 0.6, the answer is 7257. 0.7257, isn't it? This is here. 0.6 for positive sign and negative 0.6 for negative 2743. 0.2743, and the difference should be found. That is the difference. So here we write probability of is it negative 0.6 less than is it less than 0.6 is probability of z less than 0.6 minus probability of z less than negative 0.6. The first area left side of 0.6 is bigger, 0.7257 minus the left side of negative 0.6 is 0.2743. Subtract this one, you will find 0. 7 minus this 4, 5 minus 4 is 1, 12 minus 7 is 5, it's 4, 4, 5, 1, 4, 4, 5, 1, 4. That's the end of this problem. That's the end of case B. Now case D. Case D. How many cups? Number of cups. So find the probability and multiply by some given quantity, isn't it? So this is not the question is not probability, but we need a probability. The question is how many cups will probably overflow if 230 milliliter cups are used for the next 1000 rings. So the question is, how many cups will probably be overflow if? So probability of x greater than this one, overflow, isn't it? So it should be greater than of this. So x should have been greater than 3 to 30. You will take 2x is equal to 230 and then you will find result. X is equal to 230 will give z is equal to 230 minus 200 over 15, which is 2. So probability of x greater than 230 is equivalent to probability of z greater than 2, which we can write as 1 minus probability of z less than or equal to 2. So find the area left side of 2 and subtract it. Left side of 2. What is it? We will go to the table. We go to the table 2, left side of positive 2. 2 is here, 9772. 9772, right? Okay. So the formula says that probability of z greater than 2 is 1 minus probability of z less than or equal to 2, which is 1 minus 0.9772. The answer is 0.0228. And we have concluded a problem number. No, not yet. For the next 1000. So how many cups the question? So multiply probability by the number. So number of cups. Number of cups. The answer is there in the next slide. Is equal to 1000 into 0.0228. Is equal to 22.8, approximately 29, very near to approximately 29 cups more unit. Right? Okay. The last case is D. Below what value do we get the smallest 25% of the rings? Below what value? We want x value, isn't it? There will be some x whose for small x for which the area lying left side of it. Below what value? Probability of capital X small x less than small x. We can straight away go to find z and then find x. 25% of which is 0.25. The area lesser than x is 0.25, isn't it? So we need to find z value for this one, the corresponding z. Therefore, probability of z less than small z is 0.25. What is the z value for which the left side area is 0.25? From the table of 0.25, we have to find. You will find z is equal to negative 0.67. Let me verify it again on the table. The left side area is 0.25. Go for area now. 0.25. These are a positive side. You will get area more than 0.5. So left side 0.25 is the area. 2500. You are looking for 2500. 0.25. Where is it? 2500. 2514. 2483, which is nearest to 1. 25464 away. 2514 is somewhat near to 2500, isn't it? The nearest value is 2514. So on the left hand you will get 0.6. On the top it will be 7, negative 0.67, isn't it? This is it. Negative 0.67. That's right. So we are right. So there is a probability of x less than small x, which is equivalent to probability of z small z, that is capital Z. The area is 0.25. Therefore, from the table, we will get z value is negative 0.67. And the formula is z is equal to x minus mu over z. And z is negative 0.67. We are going to find x 200 over 15. Now cross multiply. How to write the formula? Negative 0.67 times 15, and this negative 200 in the left side, it will be positive 200 is equal to x. So calculate this one. You'll get x is equal to, you get x is equal to 189.95 milliliter. 189.95. That's the end of this problem. Let's go to the next problem. The answers are here. Let me check. And that's the last problem in our collection of problems for week 7. Research scientist. See, all these are applications of Z transform. I mean, normal curve, isn't it? And there is another topic called application normal distribution after midterm, but the same kind of problem. So only one problem will be there in that topic to discuss. Now let's start. A research scientist reports that mice will live an average of 40 months. Average of 40 months. This is our mu. When their diets are sharply restricted and then enriched with vitamins and proteins. Okay. Assuming that the lifetimes of such mice are normally distributed with the standard deviation 6.3 months. Average is 40 months, standard deviation is 6.3 months. It means most of the 66 point something percentage of the mice will live 40 plus 6 or 40 minus 6 in this duration, right? In the interval. Find the probability that a given mouse will live more than 32 months. Probability, we got to find probability. Probability of x greater than 32. This one, probability of x less than 28. Probability of 37 less than x less than 49. In each case, we have to find z. Case A. X is equal to 32 gives z is equal to 32 minus 40 divided by 6.3, which is negative 1.27. So case 1 is probability of x greater than 32 is equal to probability of z greater than negative 1.27. So which can be written as 1 minus probability of z less than or equal to negative 1.27. So you find this one from the table, negative 1.27. What is it? on the table and then you will come back. Go off, no problem. Negative 0.127. Negative 1.27. No, it's here. Negative 1.27 is here. 89. That is good. Negative 1.27. 1020. Okay. So for the first problem, we will write, which is the answer is here. We will write probability of 1 minus probability of z less than negative 1.27, which is 1 minus 0.1020, and the answer is 0.8980. So less than 28, case B. X is 28. Find Z. Z is 28 minus 40 divided by 6.3. This negative 1.90. So probability of X less than 28 is equal to probability of Z less than negative 1.9. Directly find the area left side of this negative 1.90 from the table. The answer is the answer is 0.0287. Verify the table, right? And between 37 and 49, case 3. Case 3. So when X is 37, what is that? 37 minus 40. 40 is our average. So divided by 6.3. It is negative 0.48. When X is 49, what is it? It is 49 minus 40 divided by 6.3, which is a 1.43. So probability of 37 less than X less than 49 is equivalent to probability of negative 0.48 less than Z less than 1.43. So find the probability of find the area from the table which is lying left side of 1 point. So this should be done probability of Z less than 1.43 minus probability of Z less than negative 0.48. From the table we find two probabilities. Left side of 1.53 is bigger, and then subtract it from the second one, isn't it? Then we will end. Okay, we will go to the table again. Well, I will show you or the property here. The first part is 9236. The second part is 3146. Verify, you can go to probability is it less than 1.43. 1.40129236. 1.43. 3 is this one. 1.49236. Next, the area left side of is it of negative 0.48. Negative 0.48 in this side end. 0.3156. 0.3156. So the answer is 69236 minus 3156. The answer is 0.6080. That's the end of this problem. And that's the end of all the problems of week 7. And thank you very much. Okay, this is the answer. From the table, you can verify whether the area less than negative 2.17. Isn't it? So for case A, I will verify, and other problems you have to verify for case A. 950 answer, it will be removed from the slide. You can check. So okay, I leave it to verify. 98 0.015 or not, less than negative 2 point, less than negative 2.17. 2.1 is here, 7 is here. So 0.0150, 0.0150 is subtracted from 1. So that is your property. For other problems, B, what is x? X is given. So find z. Z is 22 minus 30 divided by 6. So we get z is negative 1.33. Now, normal curve area to the left of x, you will write property of x less than 22, which is equivalent to property of z less than negative 1.33. From the table, directly you can find the area 0.0918 from the table. Therefore, go to the negative value side and choose negative 1.3 and check the column of 0.03. We'll find this area. Now C, question number C. Normal area between x is equal to 32 . Normal area. Now between two different values of x. C. Let's start. What is it? When x is 32, what is it? Problem number C we are solving. X is 32 gives z is equal to 32 minus 30 over 6. It is 2 over 6, 0.33. So this is first z value, z1 we call it. X is 41, what do you get? Z2 is 41 minus 30 over 6, which is 1.83. So the property of 32 less than x less than 41 is equivalent to property of z1 is 0.33 less than z less than 1.83. And we need to find the area between these two values. Find the area lesser than 1.83 from the table. It will be showing you 0.9664, right? And again go to the table, find the area below this value and remove it and subtract it. It will be 0.6293, the area below this value, isn't it? Is it the area below this value is it from the table? This is 6293. The area below this value of is it? So subtract it, you will get 0.3371. Okay. Now I think the idea is clear for normal distribution. So we stop with this problem. We move to two more questions. Now 80% of the normal curve. Okay, read the question carefully. D. The value of x that has 80% of the normal curve area to the left. So draw the graph roughly. 80% of the total area is 1, 0. 80% are below the, so are left side of this x value. So it should be more than 0.5, isn't it? So 0.5 here, 0.3 here, totally 80%. Below this value, this x will give you a z value. The relation between z and x is z is equal to x minus mu divided by sigma. We know mu, we know sigma. We should find x value. What is x? The question. And we should find z from the table. For 80% area below this value, then what is z from the table? This, the z. Z. We will find z. You can find the z from the table. I will show you. Now I write z equal to 0.84. Now use 0.84 here. 0.84, which is x minus mu is 30 divided by 6. So multiply this 6 here. 6 times 0.84 into 6 plus add this 30 will be x value. So what is x value? X value is 35.04. Now, how do you get 0.84 as is that 80% area? 0.8 should be the area, isn't it? So, below which value of is that this area is available? Check that. Table. 0.8 should be the area. 0.8 and 0 in the positive direction. 8000. Do you have 8000? Area. We are near to 8000. This is 23 units away from 8000. This is just 5 units lesser than the 8000. So the nearest value is 0.7995. Therefore, this 0.8 and the top will give 0.4. 0.84. Our answer is right. This result should be found from the table. Okay. The last problem from this problem, last part of this problem. Two values of x that contain the middle value 75% of the normal curve. I think I'll stop here by giving some idea. Two values of x, middle value. So there should be an x here that will give you z1. The same x in positive sign here. The two values of x that contain 75% the middle value. So middle value is 75%, 0.75. Area is coming here. So this is x in negative, the same x in positive. So z is in negative, the same z in positive. If you find z value from the table, then you can calculate x by using the formula z is equal to x minus mu over sigma. So how to identify the area? This 75%, so 25% will be in this side together. Divide 25 by 2. 25% means 0.25. Divided by 2, you get 0.125. So here it is 0.1250 area. Here 0.1250 area. So add these two, you will get the area below this z value. So you can find z value, probability z value, which gives the area 0.1250 plus 0.75, which is 0.8750. When you take 8750, z will be 1.5, and therefore negative z will be z1 will be 1.5, z2 we call it negative 1.5. Use these values to find x value. This formula. Try yourself, and the rest will be discussed in the next class. Thank you very much.